Okay, hi guys, how are you? So today we're doing grade 10 physical sciences. Hi guys, so we're doing grade 10 physical sciences. We're doing metamaterial. I'll just share this. So we're doing metamaterial, right? So we know that matter is made up of particles that are atoms and molecules, and matter is made up of particles, and it is the properties of the atoms and molecules that determine the characteristics of that matter. So the properties of matter include strength, density, melting, and boiling point. Remember, this is a revision from grade 9, so we should be knowing this. And then we have elements and compounds, and they are classified as pure because they contain particles that are all the same, right? So elements and compounds contain particles that are all the same. Substances can be classified as pure. As explained, they contain particles that are all the same. Yes, so for an example, element sulfur can be represented as S, and carbon as C, and phosphorus as P, right? We also have compounds like water that can be represented by H2O. We have sulfuric acid that can be represented by H2SO4, right? So they are rules in naming compounds. So the metal or hydrogen is always named first. Remember, this is revision. Is always named first in the compound name, and then the non-metal would come second, right? Yeah. So mixtures of substances usually consist of substances and can be homogeneous. Remember, that means they have the same look throughout, or they can be heterogeneous, and then that means they're made up of different substances, right? So they can be separated in various ways. Physical separation, like for instance, filtering and distillation, right? And they can be combined by dissolving one into the other, or it can be separated by using a constituent. So some of the properties of metals are that they conduct electricity and heat, and they are malleable and ductile. So non-metals and non-conductors of electricity and heat are gases, right? Okay, non-metals are non-conductors of electricity or heat. That's what I meant. And then examples of them are gases and brittle solids, right? So there are two states of matter. Okay, there are different states of matter and kinetic molecular theory. So the kinetic molecular theory, together with the intermolecular forces, explain to us that matter can exist as solid, liquid, or gas, right? And the kinetic molecular theory also can be used to explain the diffusion and motion of the different particles, right? And then there are spaces between particles. You know, the solids, the spaces will be much smaller, and then for liquids, the spaces will be a bit more, and then the spaces are the greatest when we're talking about gas, right? And the melting point of solids is usually higher compared to liquids. And then, so the gas usually has the lowest melting point, right, of all the phases, right, or the states of matter. And then coming back to atoms, atoms we did say is a basic building block of matter. So matters are made of atoms. So yes, matter, the definition, we still remember this from grade 9, is a substance that has mass and can occupy volume. Number of models, a number of models have been developed by different people to structure the atoms, right? So we have, gonna look at Thomson. He developed the current band model, so that can see how the atom consists as a solid and is positively charged mass with tiny negatively charged particles that are scattered. Okay, let's move on from that. So the structure of an atom will be atomic number plus number of neutrons. So the mass of an atom will be the atomic number of the atom will be the atomic number of the atom and the number of neutrons. That will be the mass of the atom. So an atom can either gain or lose electrons in order to form a charged particle. So that charged up particle is called ion. So a positive ion is formed when an atom loses electrons, right? And then a negative ion is formed when the atom gains electrons. Remember, there's movement of electrons. It either loses electrons or gains them. So if it loses them, then it becomes positive. If it gains them, then it becomes negative. Remember, electrons are negative. So the mass of an atom is determined by the number of protons and neutrons, right? The mass of a proton is equal to the mass of a neutron, which is 1 unit mass, right? So, okay, isotopes are atoms of the same element that contain the same number of protons but have different number of neutrons. They are called isotopes. They have the same atomic number but different mass numbers. So in the periodic table, two numbers are given with the symbol of each element. These numbers are the atomic number and the average atomic mass. In any event, so the ratio of the isotopes is constant, yes. The atomic mass is given as the average mass of all the atoms in the sample of the element. Right, let's move on. So how we can configure an electron, it looks like this. So electron configuration refers to the arrangement of electrons in an atom. Electrons occupy orbitals arranged within energy shells, right? So the orbitals would be around the center, right? Around the nucleus. So these correspond to the periods in the periodic table. So yeah, it looked like this. So the electrons orbit the neutron, which is the will orbit the nucleus, which is the center of the atom. So they will orbit like this, and they will correspond. The number of the electrons will correspond to the periods in the periodic table. So we look like that. So sorry about that. So here, fluorine contains 9 electrons, right? Because of its position on the periodic table. So this means its electron configuration is 1 s2, 2 s2, and yeah, so all of them together are 9. 5 plus 2 plus 2, that will be 9. So its configuration looks something like that. Okay, it has 9 electrons because its configuration is 1s2, 2s2, and 2p5. So all of them together is 9. It has 9 electrons. So as you can see from the electron represented by arrow, so the energy tends to increase. It's higher when you get closer to the center. You must always fill up the lower orbitals before you can move on to the next energy level. So you start with the lowest energy level. That's how you configure the atom of the electron. So this is the periodic table that I've been referring to. We should know it by now. Let me try and zoom this out. Yes, so it looks like this. We know all the elements. I hope. Okay. Yeah. So the elements of the periodic table are arranged in an order of increasing atomic number. We can go back to this. So hydrogen will have the lowest atomic number, right? Will have the lowest, and then followed by helium, and so forth. And then the third one will be lithium, and so on until you get to the last one. So that's how they are arranged. So and then the numbered columns are called groups that are numbered from 1 to 13 to 8. Sorry, from 1 to 8. If the transition metals are included, then the numbers run from 1 to 18, right? So the numbered arrows are called periods. We can always go back. So the numbered arrows are called the periods. In some groups of the properties, of the elements in the group are similar, right? So there'll be alkali metals in group 1 and non-metals of halogens in group 7. Okay, so the properties change gradually as you move across a period. For an example, you'll change from a metal to non-metal, and the characteristics that change across the periodic table include the atomic radius, and this is this distance from the center of the nucleus to the outer energy shell, and it increases down a group and across a period. So in each period, the last element in the period will have the biggest atomic radius, right? And the first one in the group will have the smallest one. Yes, and they are also arranged in ionization energy. So this is the energy needed to remove an electron from an atom of that element in the gas phase, and it also increases across a period but decreases across a period. So in a group, the first one will have the highest ionization energy, but the last one in the group will have the lowest. So electron affinity is also one of the ways the elements are grouped. So this is the energy that change when an electron is added to an atom of an element in the gas phase, and it increases across the period. So they're also arranged according to electronegativity, and this is the ability of an atom to attract the electrons, making a bond it is involved in, and increases across the period but decreases down the road. Okay, so chemical bonding, I'm sure we've seen this before as well, is in chemical bonding, like the electrons found in the outermost energy shells are known as valence electrons, and they control how an atom reacts. So the electrons that are found in the outermost energy shells are known as valence electrons. And remember, they control how an atom reacts. So the number of valence electrons are equal to the group number. So all the elements in the group will have the same number of valence electrons. All atoms try to get a full outer shell of electrons. Yeah. Um, okay, they can achieve trying to get all the full number of electrons in the outer shell by gaining electrons from another atom. So losing electrons to another atom or sharing electrons with another atom. So they can fill all they can have full outer shell electrons. So we have covalent and ionic bonding, right? And we can show the different bonding using the Lewis diagram. So Lewis diagram, we use dots or crosses to represent the valence electrons of an atom. And rules for drawing the Lewis diagrams is that we write the symbol for the element and then draw a cross or a dot on top of the symbol, right? Remember, we work clockwise, and then the electrons are only paired once. The first four dots or crosses have been drawn. So you only pair the electrons after you've drawn the four dots. Okay, so the formation of electrons of ions. Sorry, an ion. Remember, we did touch on this. Is a charged particle that either negative or positive. It's positive if it loses electrons, and it's negative if it gains electrons. Right, if the atom gains or loses the electrons. And the atoms lose or gain electrons in order to obtain a full outer energy shell. Right. So the charges go like this, as per the table. So the charge +1 would be in group 1. Group 2 would have +2. Group 3 would have +3. Group 4. The elements in group 4 do not form ions. In group 5, when they have full outer energy shell, they have -3 as a charge. Group 6 has -2 as a charge, and then group 7 has -1. So elements in group 8 will not form ions as they already have a full outer shell of electrons. So they won't lose or gain any electrons because they have a full outer shell of electrons. Alright, so we're going to talk about the different types of bonding. The ionic bonding occurs when two metals come together, and then they form positive ions, right? And when non-metals come together in ionic bonding, they form negative ions. Ionic bonding follows the following rules. The metal will form a positive ion with a charge equal to the number of electrons it has lost. The non-metal ion is written in square brackets. Its charge is equal to the number of electrons gained. Right? So before it gains or loses any electrons, it doesn't have a charge, right? And then if, depending on the group it's from, if it gains or loses electrons, then that charge. Okay, so the non-metal ion is written in square brackets, and its charge is equal to the number of electrons gained. The square brackets must contain the transferred electrons as well as those of the non-metal ion. So when you draw it, its original electrons have to be included and the ones that they've gained, right? So now we're going to talk about covalent bonding. A covalent bond is formed by overlapping orbitals that share a pair of electrons. So in this way, both atoms obtain a full outer energy shell, right? Water is an example of a covalent compound. Each oxygen atom requires 2 electrons in order to obtain a full energy shell. This means that 2 hydrogen atoms are needed. So in this case, 2 single bonds are formed. Okay, so this is how water is formed. So to form H2O, oxygen needs to bond with 2 hydrogen atoms, and then they form H2O. They transfer electrons from between each other and then form a molecule H2O. Okay, so we have metallic bonding as well. So metallic bonding, in metallic bonding, the valence electrons of metals are loosely held by the nucleus. They move out of position and become delocalized, or they're called free electrons, right? Because they move, they're loosely held by the nucleus. And then the structure is held in place by the strong electrostatic force between the positively charged metal ions and the negatively charged delocalized electrons. So that's how it stays in place, because the electrons are negatively charged, and then the metal ions within the bond would be positive. So the negative and positive obviously attract, and they are able to stick together that way. Yes. So particles that make up substances in covalent molecular substances. Molecules are formed when non-metal atoms are covalently bonded together. So they can be represented by using different circles. So each atom is represented by a circle of a different color. So it's a different way of representing the bond compared to covalent bonding, for an example. And then the ionic substances in the substances, ionic substances are also known as salts, and are formed when a metal atom transfers electrons to a non-metal atom. So the electrostatic attraction between the positive and negative ions is what holds the crystal lattice together. So this is a bit similar, but not the same to metallic bonding. So the covalent network structures. The covalent network structures are giant molecular bonding that are formed by a large number of atoms that are covalently bonded together, right? So if the the atoms are covalently bonded together, they create covalent network structures, and they form a regular lattice. So a diamond and a graphite are example of such covalent network structures. So a diamond or a graphite, I think another example of graphite is like a chalk. They're bonded that they retain their shape using the covalent network structures. Okay, I'll end here. Thank you very much. Okay, I'll end here. Thank you.